Hello, this is Mr. White, and this video is on determining domain and range graphically. And hopefully you've picked up some sense of domain and range in class, because this is going to be sort of a medium to hard level example. So real quickly, if we summarize, the domain is basically all the x values exhibited by a function, and the range is all the y values. And the good news is that just like D comes before R in the alphabet, X also comes before Y. So with that in mind, it's pretty easy to remember that domain is X values, range is all the Y values. So this is the example I've chosen here. This is one of those beautiful rational functions that populate my dreams. It's called a rational function because it is the ratio of two polynomials, and rational functions tend to give us some really interesting shapes. So go ahead and type this into your calculator. As always, I'd like you to be an active listener and follow along here. TI-84 users, I'll remind you, if you don't already know or remember, that to get a nice fraction into your TI-84 calculator with a newer operating system, go alpha and then F1 right above the y equals button, and then hit enter to get the numerator over denominator format. And that's how we get that nice fraction bar. And if you have a TI-84 that does not do that, bring it to me and I'll upgrade it to the new operating system. TI-83 users, I'll remind you that you don't have that functionality, but you can still take care of business. Type it in as I've shown here, being very careful to get those parentheses correctly located. So again, pause the video if you need to, get that on your screen, go ahead and hit zoom standard, and you should see something that looks kind of like this. Now I'm not displaying it with the calculator, but your graph should look like that. This is a screenshot of the GeoGebra program that I like to use, and I'm going to use that in this example because I think it'll help me better illustrate my point. Okay, so if you don't have a graph that looks like that, look closely at your equation, make sure you're in zoom standard, and we'll go ahead now. I'm going to pull up GeoGebra here, and domain. Domain makes me think of this vertical line sweeping across the page. So notice that I've hidden all the numbers along the y-axis. I'm really just focusing on these the values on the x-axis. And as I sweep this vertical line across the page, likewise, I'm showing the coordinates of the where this line intersects the graph, and I'm only showing really the x-coordinate, so we can focus on that. And kind of keep track of all the numbers that we're seeing there, all the numbers that pop up, and also notice the number that doesn't pop up, or numbers that don't pop up. We're really keeping track of where this line hits the graph and where it does not hit the graph. And that's what we're trying to record with domain and range. So let me go ahead and do that again a little bit more slowly. So as we sweep from the left here, I'm off the screen right now, but it's just coming onto the screen, and we're kind of imagining that this graph really went all the way infinitely far to the left. So we would say that the x values went all the way to negative infinity, and now I'm coming upward. I'm still negative territory, but the numbers are getting bigger. And so I went all the way from negative infinity all the way up to, right now, -1, and now up to 0. And we're still going, we're still growing. But here's our first sign of trouble here. We're getting really close to the end of this first branch of the graph. And you can probably see where it's going to completely miss the graph. There's this narrow little alley here through which this line passes, and I probably mentioned in class, I've told you a little preview of some upcoming material, that this is called an asymptote. And that's where we don't have an x value of -1. There is no point on this red graph where the x value is -1. And likewise, this vertical line, which exists at x equals -1, doesn't touch the graph. There's no point on the graph where x is -1. So that's how we're going to record that. Let me shrink this a little bit here, and I'm going to record that by saying that the domain, again, we say we started way back at negative infinity and we came all the way up to 1, but when I finally got to 1, it didn't touch. There was not a point there, and that's why we use the parentheses there to say that it stopped just a little bit shy of 1. So again, what I just wrote there covers this one branch of the curve, but we're not done. We've got 2 other branches to consider. So let me go back to GeoGebra here and keep on sweeping to the right. So okay, I'm going to pick up just after 1. So now I see that just after 1, I picked up again. I'm seeing some x values. Right now it's at 1.6. And I'm seeing all these x values. I can get every single x value between 1 all the way up to 3. And that's where my next little alley is, where the asymptote passes, the vertical asymptote. And there's no value of x equals 3 on this graph. So let me go back to my picture here, and I'm going to say that for that middle branch, I'll put this little symbol U for union, and I'll say that for the middle branch, the x values, oops, I'm sorry, not negative, went from 1 all the way up to 3. And I'm using parentheses on both of those because it didn't touch 1, it didn't touch 3, but it got every value in between there. And again, that covers that middle branch. So our final branch, if I go back to GeoGebra here and keep on sweeping to the right, I'm seeing x values appear. I'm only focusing on the x values. And it goes from just above 3. We can anticipate it goes all the way to infinity. So let me write that as union just beyond 3 all the way up to infinity. And that is our domain. So let me show you how to explore that on your calculator. Again, I found it a little bit easier to do here in GeoGebra, but you can still exhibit that on your calculator. Okay, so let's go to graph here. Oops, what did I do? It's a common error that I think I'll just leave it till class to help you guys through that. Notice I accidentally left an empty fraction here, and the calculator doesn't know what to do with that. So I'll clear that, hit graph, and while this isn't quite as slick as using GeoGebra, go to the trace button here. And again, when I was sweeping that vertical line across the screen, the TI equivalent is to just hit trace and use the left and right arrow buttons. So I went to the left there, now I'm going to the right. And notice that we're only focusing on the x values here. And just like we said that the domain was negative infinity to 1, I can keep tracing, I can keep seeing that there are points on this graph. But if I want to get to 1, notice that if I use the arrow buttons, I'll probably jump right over 1. So here x is 0.85, and I hit the arrow button and it jumps right over. So if I want to get to 1 exactly, just type the number 1 and hit enter, and notice the calculator doesn't have anything there. Again, like we established, there's no point for which x equals 1 on this graph. But if I just go to the right of it, or even if I just type in, say, 1.01, just something slightly to the right of it, all of a sudden I've got a y value, and I may not see it on my screen, but this y value establishes that the point is there, it's just off the screen. And I keep going to the right, and we go to the next point that we said we didn't exist on this graph. I'll go ahead and just type in 3, hit enter, and again I see another blank. So the 1 which was not included in the domain over here, and the 3 which is not included in the domain, what we're seeing on the calculator is consistent with that. As I go to the right here, I'm seeing that this point does exist on the graph. Range is a little bit more tricky to do on the TI-84 because when we trace, we're really we're typing and controlling x values. But let me go ahead and go back to GeoGebra for range. And same idea. The main mistake that students make about range is we're so used to reading from the top of a page down to the bottom that I think a lot of students tend to do that. But we need to go from negative to positive. That's one thing I really need to emphasize here. Notice that in the domain, your numbers should always go from negative to positive. They should always be growing. Negative infinity grows up to 1. 1 grows up to 3. 3 grows up to infinity. It should be always increasing or growing like that. And same thing with the range. Range, I'm going to picture a horizontal line sweeping upward. So notice I'm going to do this one a little bit more quickly, but I'll stop at a critical point here. Don't worry about the fact that there are 2 branches of this graph. We don't have to do anything special in writing our range to accommodate that. But notice I'm just showing the y values, and actually, let me go to, let me change something on the display here. I want to display just the y values here, so just bear with me here for a second. I'll turn off the numbers on the x, I'll turn on the numbers on the y. There we go, that's what I wanted. So notice the y values along the y axis. And they went from negative infinity all the way up to, and where are we stopping short? It looks like we just stopped short at 2. So I'll go back here and I'll say that the range goes from negative infinity, starting at the bottom of the screen, sweeping upward up to 2. It stopped just short of 2 because that's where we had a horizontal asymptote. And unlike the domain where we picked up right where we left off, I stopped at 1, but then I picked up at 1, and I stopped at 3 and picked up at 3. For the range, notice there's more of a gap here. It stopped at 2, and I'm still going up, and I'm not touching the graph at all until I get to 6. And this is just a little GeoGebra glitch here. Don't worry about the fact that that's shown twice. I have a y value of 6, and it actually does touch 6. There's no asymptote there. It's actually touching at 6. And as I go upward, it gets all the y values up to infinity. So the different way we're going to notate that is we're going to say it actually touches at 6. That's why we use the bracket, and goes up to infinity. That is our domain, and that is our range. How you do that on the calculator is a little bit trickier, but I'll give you a little tip here. Again, this is sort of a little bit more difficult problem than you'll often see. I'm going to say if we notice that in the domain that we had that asymptote there at 1 and at 3, it would be reasonable for you to assume that this middle point here aligns with 2, which is halfway between the 1 and the 3. So we're having to use a little bit of deduction here. And so on your calculator, go ahead and trace to that point 2, halfway between the vertical asymptotes. Hit trace and go to 2. So trace 2, enter. And notice that that's where I see my y value of 6. That's where I pick up at a y value of 6. I'm focusing on the y value now. If I go to the right, it's growing to infinity. Or if I went from 2 and then went to the left, it's also going upward. So that confirms our range. Again, there's the domain and range of this function. I hope that was helpful. I'm going to have you try one now and see if that made sense. So try this one, and as usual, go ahead and pause the video, try it yourself, because in just a moment I'm going to reveal the solutions. Okay, hopefully you've tried your hand at it, and if everything went well, you should be getting a domain from negative infinity to negative 5. Negative 5 to 1, and 1 to infinity with parentheses. And yes, you do need to list them in that order. And the range from negative infinity to 2 inclusive, using the bracket, and then 3 to infinity. Notice we never use a bracket on infinity because you can never reach infinity. You can never touch infinity. You can just keep going and going and going.